Welcome everybody to this third and last workshop of the project UDENE. I'm Daniele Oxoli from Politecnico di Milano. Today, just here for moderating and introducing the presentation. So I won't steal too much time to our speakers, but the agenda of today include the introduction of the project provided by our project officer and managers, and the overview on the opportunity and the tools that are developed within the project. And we will pass later to the use cases with a focus specifically today on the use case of Istanbul. So just some information about questions. So we will have a question and answer session at the end of the presentation. We kindly ask you to provide your questions through the, not through the chat, but through the question and answers tools that is included here in the webinar, and then we will catch up at the end with all the questions. We will have time also for live discussion. Without adding other details, if I didn't forget anything of relevant interest, I can pass the speech to Ali, which is our project manager, for the introduction to the UDENE project. So please, Ali, the floor is yours.
Yeah, thank you. Well, I want to make a short introduction and tell about the project concept. So let me share my screen. I'm sorry that I forgot the UDENE background is blue, so I'm wearing blue shirt. It's not good. All right. This project is funded by EUSPA, European Union Agency for Space Program, which was using the Horizon Europe program to fund projects that use Galileo Global Positioning System and Copernicus Earth Observation Satellite Network. And we applied for this call with a project idea based on urban development. And I will now brief our project and try to explain why is it relevant in educational context. Okay. Today's focus is on Istanbul, Turkey, where we had a use case, one of our 3 use cases on earthquake preparedness. And yeah, right after me, there will be presentations on the open call itself, its scope and expected outcomes. And then we will demonstrate our tools and talk about the Istanbul use case. Okay. So Copernicus is a satellite network of currently 12 satellites equipped with various cameras and remote sensors. It's basically, they capture almost every observable property of a spot on the planet every 3 days. Some places more frequently, but at most once in 3 days. That's a huge amount of information, actually 20 terabytes downloaded to data centers, 2 data centers actually every day. And then all this is dissected and appended with new data sets, local or what we call in situ data sets, forming the Copernicus data space ecosystem. We're talking about a lot of data and a lot of potential. So the potential that we have seen there is to see natural occurrences of urban development ideas, which for example, if there is let's say a bridge planned for a city, if you can find similar places to that city where such a bridge has been made, you can check if your intended outcome actually took place, which was, let's say, easing the traffic. So using that observation data, you can check if this place has eased traffic due to that bridge. This proves your assumption, your starting hypothesis that such a bridge would be useful for your city. Or maybe you can find places, similar places with much easier traffic, but that was not due to a bridge. It was due to some public transport project. So then you can maybe reconsider your urban development idea. This is the first objective of UDENE. Second objective, of course, to find these intended outcomes taking place in the other places, we need to search, we need to use models and search a data cube so as to do the search fast enough. And these models, of course, needs to be verified in terms of causality. We use some newly developed sensitivity analysis algorithms for that purpose. And the third objective is to promote Copernicus services, especially to Copernicus international partners, such as Turkey, Serbia, Tunisia. These are outside European member states, but still denoted as Copernicus international partner countries. Now, there are three cases, and today's topic, Turkish case, have a particular intended outcome. Like for the Turkish case, high-rise buildings not affecting earthquake economic loss. Now, to model this earthquake economic loss, we use global premium settlement layer, a kind of data from Copernicus data system, data space, and urban atlas building height, and many others. So these two are the top types of data. Now, I want to relate right at this point to the context of our open code, the data science education. Since we are using different kinds of data, and to do that, we have to resolve how to access this data, how to render it, give search fast, how to align it in terms of time and space with other types of data. All that is covered by UDENE tools. So it also presents a good opportunity to teach these, to train new aerospace engineers or geometric engineers or geodata scientists on these practical techniques. So why not use this tool actually for urban development in the context of education? So that brings us to this first open call. So if you prepare an educational plan with assignments or teaching context borrowed from, let's say in Turkish case, human settlement layer or urban atlas, then you can use UDENE tool to fashion these assignments fast, very easily, and the students can use the UDENE tool to realize those assignments. That's an opportunity for the data science community of the country, right? But of course, you can use the Serbian use case and its data as a context, or Tunis case. Those are also, of course, possible. Now, about the modeling part. So, as I said, we are trying to model the intended outcome of the urban development idea. That's because usually such intended outcome is not readily observable as a data set accumulated over time. If that was the case, we could just use it to find the places, but that's not usually the case. So we use a model which consists of other variables as a proxy of this intended outcome, and that gives us this rich data sets to play with. We need to access all these data sets, put them in the data cube, make them searchable, align them, and all that. So that's the opportunity to in a educational context, talk about what kinds of data are available through Copernicus Earth observation system. And how do we do it? Actually, we do it in two steps. The first step is to limit the search space because the entire world is too big to search. For instance, in Istanbul case, this earthquake preparedness, obviously not every place on Earth is an earthquake-prone area, so we can actually limit the search space to those characterizing this and as a first step, and then we can try to find the proxy of the intended outcome. And in that proxy, we try to use the variables that are expected to change if such an idea takes place. For instance, if the idea is about high-rise neighborhoods, then we should involve earthquake economic laws as sensitive to building height or residential average number of floors in a residential area, that sort of thing. So in that proxy model of the intended outcome, we try to find the outliers. And this is with the assumption that the outliers cities or districts, areas of interest must have done something to be an outlier. If it is the original urban development idea, there we have an evidence that it works, but again, it may be some other reason why they are an outlier. That's why once we find these places, we just display it to the user and let the user explore the place to figure out what has been done there to achieve this outlier status. So that's, in a nutshell, what the UDENE project is about. And we also have a second tool besides this exploring natural occurrences tool. It's the exploration tool. We also have a matchmaking tool, and this is a very practical thing, actually. Using the Copernicus system, hundreds of different services and products have been developed and promoted to market in Europe by various providers, some governmental, some for profit. But all these are listed in an archive page you know. What we do, we link this EOMO database of Earth observation products and services to the exploration tool input areas for the user, where the user inputs his or her urban development idea, selects intended outcome from a set of options, selects the model. So when the user is doing this input operation, we use natural language processing to find unlikely keywords in the text and then search this database of products and services, Earth observation to find the most relevant ones and display down the screen so that such a user may click that and study this available product or service, and maybe there is a business relation stemming from this interaction. So that's why we call it matchmaking. It's a business matchmaking. It's actually refers to, but this is a secondary practical tool we are employing. Okay, so that's briefly the UDENE project, and I will now hand over to my friends to talk about the scope of this open call. Thank you.
Thank you, Ali. We now introduce Maya for the presentation of the open calls. Meanwhile, I would just forget before to tell you that both the presentation and the recording will be available through the UDENE channels in the next days, also for this webinar as for the other. So please, Maya.
Thank you, Danielle. Thank you, Ali. My name is Maya Stremački, and I will try to orientate you through the UDENE Open Call webpage and to show you what materials you can find and where to find them. And if you have any questions, please ask them in the Q&A section, and we will try to answer them all throughout this webinar. If not, we will answer them via frequently asked questions database in the form of the document that will be published on UDENE website. So you can find all the answers to the previously asked questions and the questions that you asked here if we do not find the time to answer them in this hour and a half that we have. I hope that you all see my screen. So mostly I will talk about this on web page that is on UDENE website. So what are we offering? Where are the documents? How to apply? And go through all the procedure of the UDENE open calls that we have for now for you. I will touch up on both open calls, not just the first one, which because both of open calls are live. Because we opened the first one and the second one very closely, so I will go through them both. So this is why our UDENE open calls is July, August of 2025. So what is the timeline? You can see the brief timeline, which is on the right side of the screen. It's on our website. So the first open call opened on 8th of June, which means that it's going to be ending on 16th of August. And then we proceed to the procedure of evaluation and selection of winners and contracting. And we will finish the contracting on, we hope so, by 15th of September. And the second open call was opened on 1st of July, and it will end in 29th of August. And we also think that hope that we will finish everything with the evaluation and contracting by the end of the September. So we can start with both developments of the for the winners of the project for both open calls on October 1st. So you will have 2 months to develop your ideas and to submit your reporting on December 15th. So these recordings of previous webinars, so for Serbia and Tunisia and for Turkey, are for Serbia and Tunisia already on our YouTube channel, but this one will follow very fast, and you can see all the material on our channels, as Daniela said. But these dates are the dates that we are trying to follow, but it can change a little bit due to something unexpected happening. So we can be a little, let's say, flexible in some dates, not most. Okay, the next thing is open call 1. These are the credentials that you can use. So we can use the form for the first one with the credentials you can see on this screen, and everything is also on the open calls webpage. You can find it in the end of the webpage. Also for Open Call 2, Open Call 1 is UDENE Tools Integration in Geodata Science and Education. You can access it through the link on the left. And the Open Call 2 is UDENE Tools for Global Business Solutions that accelerate Copernicus adaptation. You can access it through the link on the right. Most of the links that are in this presentation, after the presentation, I will share into the chat, so you can go through them while watch the webinar, or you can just copy paste them into somewhere so you can browse through them later on, so you can have them all in one place. So next, webinars that we already have, as I already said, Serbia on 9th July, Tunisia on 10th, and now we are in this webinar for Turkey. Actually, all 3 webinars had the same structure. The only thing that changed was that in Serbia webinar, you had a more in-depth showcase of Serbian use case, and in Tunisia webinar, it was more in depth about Tunisian use case, and today we will have more in-depth demo of Turkish use case. So if you watch the webinars, you know what you can expect. And we have 3 more info sessions for Serbia on 11th of August at 1 p.m. All of them are going to be at 1 p.m. For Turkey on 13th of August and for Tunisia on 15th of August, which is kind of good because as I already said, Open Call 1 is ending on 16th of August. So before the ending of the first Open Call, you will have these info sessions where you'll touch up on the things that we talked about on webinars and mostly focus on your questions. By this time, you will all go through the material that I will show you where to find, and you will need for your preparation of the submission of your application. And then you can have 11th, 13th, and 15th dates to ask questions for clarification, or if you have any things you need support from us to explain a little bit better or closely, or whatever you need. So you can ask live, and then we will incorporate all of the questions and answers into the same document, frequently asked questions, which will be our database for your questions and our answers. Registration links for the Open Call info sessions will be, I think, published by the end of this week. So you will have the scope of it clearly. You can then plan. The next part I want to talk about the UDENE Open Call webpage is the things that we provided for you to help you apply for the Open Calls. So the Annex 1 is Open Call fichiers, where we explain all the procedures for Open Calls. We explain the timeline in detail, what are the eligibility requirements, who can apply for which Open Call, when it's going to end, then what you need from your documentation, how the documentation is going to look like, etc. And then Annex 2 is Guide for Applicants, in which we explain how our tools work. So demonstration you will have today, live demonstration, but in detail, in this guide, you have everything explained in detail about the tools that we provide for you to use to prepare your application, and not to use to prepare your application, but to use if you win the Open Calls through your for your idea. Then you have three documents: Annex 3, Annex 4, and Annex 5, which you will need to download and fill out and send us with your application, which is Declaration of Honor, Ethical Intellectual Property and Security Declaration, and SME Financial Stability if you are an SME. So if you are not an SME, this document is not going to be needed for you. And the last document is Annex 6, Model of Sub-Grantee Agreement, which is good for you to see an overview of what the contract between us can be, and then to be prepared for this contracting part so we can modify it accordingly to the needs of our winners. Then the part of the web page of Open Calls, where you can see what we are offering you, and where are going to be our videos and PowerPoint presentations that we use through this webinar, and where is our YouTube channel where you can follow and see all the webinars and info sessions recordings. By the end of the web page, you can see exactly what you will need to apply. So what is the first Open Call, when is the submission deadline, and the link to the form. We're going to talk about the form in a little bit, and then how you can access this form for both Open Calls. So Open Call 1, UDENE tools integrated into geodata science education, which Ali also already said it's mostly about education and ideas how to incorporate these tools into the educational field. And then the second one is more business oriented. So UDENE tools for global business solutions that accelerate learning facilitation. Our application form, it starts like this. It tells you when you can apply, from where, from which time to which time. Then when you start the application, you have 3 stages. The first stage is eligibility and feasibility. So you can type in type of application, what is the target country, Serbia, Turkey, or Tunisia, and then your contact from the person that we are going to contact for everything related to the application. So person, an entity, phone number, email, other contact persons, etc. The second stage is what will you do? You are explaining to us in brief what you are, what is your idea, what you want to do with the tools, and in which open call. Each section, so we have 4 sections. You have concept and contemporary significance, impact, relevant expertise, and work plan. Each of these first 3, you can use about 4,000 characters to explain your concept, impact, relevant expertise, and then you will provide a work plan with task descriptions in a single Excel file this size, 10 megabytes. And the last stage is a stage of the form where you can upload the documents we talked about. So declaration of honor, ethics, intellectual property, and security declaration. And if you are an SME, to upload a SME declaration and to submit your application. General propositions are there is 2 PMs, 2 person months. This work that you propose has to be feasible, so doable in these 2 months, and it has to be feasible in scope of UDENE tools functionalities. The work is going to be done through October and November of 2025. As I already mentioned, UDENE practical guidelines or guidelines for applicants is where you can see in detail what are the functionalities of the tools. And then you can also see the tutorials. We have on YouTube tutorials, recordings of demo sessions and use cases, and of course the webinars that we provided in this first open call, and then info sessions afterwards in the second call. Only single applicants shall be eligible, no consortia. And final report delivery date is, we set it as December 15th. So we have 12 winners. We have 6 winners per open call because we have 2 open calls, and 2 winners per country. It's going to be 10,000 euros per winner, so 60,000 per open call, and in total 120,000 for both open calls. Lump sum is going to be paid in lump sum upon completion of the work. So what you need to bear in mind is that if the sub-grantees introduce new data sets to be used, they will have to report data, its use, behavior of the tools, and relation to learning outcomes for OC1, so Open Call 1, or for business outcomes for Open Call 2. The identified European Earth observation product and services providers are expected to join voluntarily, not paid. And in the case of delivering an innovation solution, the provider will also deliver a white paper and the user guide. So you have to be at least ready for that. So first open call, purpose of the call, as we said, is to expand the skilled practitioners of geodata science in Copernicus international partner countries by using UDENE open source tools. What are the expected outcomes of this first open call is to grant receivers. The granted receivers are expected to deliver an educational plan with the curriculum design, educational models or course content, and demonstrative case studies. What is the purpose? What is the result of your work is going to be a feasibility report expected to meet Erasmus quality standards for educational programs. And it includes learning outcomes, curriculum of 3S at least, and competency development assignments and demonstrative case studies. This is for the call number 1. So UDENE Tools integration in geodata science education. For Open Call 2, UDENE Tools for global business solutions that accelerate Copernicus adoption. The purpose is to stimulate international business collaboration by integrating UDENE Tools into market-driven solutions developed jointly by European Earth observation-based products and services providers and local SMEs. What are the outcomes that we expect? The grant recipients are expected to deliver a feasibility report that provides evidence for the feasibility arguments they have about business cases they have submitted, which need to have market-ready business-oriented solutions, feasibility studies, and business cases. And the output is also going to be a feasibility report that describes the implementation of business case enabled by the Copernicus systems. What needs to include? Detailed business case, partnership documentation, pilot project, and market entry and sustainability plan. What is the process? How does the process look like? Application process, I mean. So you apply, so open for application, then we check your eligibility. If you are eligible, then we go to external remote evaluation. If you're not eligible, you will receive process information document. Process information documents are rejection letter, acceptance letter, proposal evaluation sheet, and or consensus evaluation sheet, depending on the part of the process or the stage of the process you're in. So in this case, if you're not eligible, you will get the rejection letter. If you're eligible, your application goes then to external remote evaluation. We have 2 external evaluators that will evaluate your application independently. And then if you do not pass the threshold of the scoring, you will also receive a rejection letter with the explanation of why your application is rejected. So if you pass, if your application is good, we go to the results announcement and contracting with the winners. In the case that there are 2 or more applicants that have the same scoring, we will then let you know that there was this situation. Your application, both or more, will go to consensus evaluation ranking, where we will all look all the applications and schedule the meeting with the participants to ask questions and for you to explain some more in detail your application, so we can score them again and make them diverse. And then in the end, which one becomes the winner will go to the process of result announcement and contracting, and we will announce the winners, and you will get acceptance letter and your evaluation sheet and report. Evaluation process is in 2 stages. First stage is to screen the screening procedure for eligibility and feasibility checks. Who can apply? SMEs, startups, NGOs, local authorities, associations, education, training organizations, research institutions. So very wide list, and based in one of the target countries and as defined in Horizon Europe rules for participation can be applicants. And stage 2 is the quality assessment procedure. So we score concept and contemporary strategy for the contemporary stage, and impact, and in the end application expertise. What is your team offering? For more information, visit our website, UDENE website. These are the links that I was talking about, so don't be scared. I will finish this slide fast, but I will put all the links from this presentation into the chat, as I already said. So our help desk in UDENE, where you can write to us with the questions. Every question you ask, we will add to the frequently asked questions database, where you can and publish weekly, so you can see the answers to every question that was asked. Even asked even if you didn't ask the question. So thank you for this, and please, if you have any questions, write them into the Q&A section, and we will try to answer it for you during this webinar. If not so, we will then share it through the document I just said we were going to make. Thank you.
Thank you, Maya. And really complete presentation. Now we can move on the presentation actually of the tools of UDENE. So I invite the colleague from Top University to take over for presenting the exploration and matching tools. In my list,
hello,
was
everyone.
Professor. Yeah. Is Deniz?
Yeah. Oh, yeah. My name
Yes,
is Oğuz Deniz. I work as an engineer at UDENE project within the top team. Today, my colleague Hüseyin won't be able to attend the webinar, so as a substitute of substitute, I will be giving the demo. I had prepared a video beforehand, so let me share my screen for the demonstration. Is my screen okay?
Yes, please.
Can you hear the audio, by the way? Is the audio of the video?
I don't listen.
Oh, okay.
No.
There
is a segment when you share the screen. Before you share the screen, you have to select include sound.
Mm-hmm.
And then it's going to include your computer sound.
I am having an error for including the sound.
All right.
Our comprehensive platform that combines Earth observation data.
That was good, thank you.
Yeah,
Hello,
now we hear.
welcome to today's demonstration. And I work as an AI and research engineer at UDENE. I'll be walking you through our comprehensive platform that combines Earth observation data, AI-powered analysis, and intelligent matchmaking to support urban development and environmental research decisions. So let's begin with accessing the platform. And first, new users can register at this tab. Here you can create your account with your credentials. Once you're registered, you can access the platform at this tab. And if you ever forget your password, we've got you covered with our password reset failure at this tab, like this. Let me log in and proceed. Yes, and now that you're logged in, you can see our main navigation with 3 primary tabs. Let me walk you through each once. Let's start with the datasets tab. Here you can see the 2 types of datasets. The first one is the in situ datasets, the first tab, and this represents real-world ground-based measurements that we maintain in our data cube. This data provides crucial ground truth for validation and analysis. And the second type of datasets is the global datasets. When you click any of these datasets, you will see comprehensive data visualizations, including various indices and spectral bands. This gives you immediate insight into the data characteristics and helps you understand what's available for your analysis. For example, for the Sentinel-2 dataset, you can choose your index channel. You can zoom in, you can zoom out like this. And next one is our experiments tab. Here there are 2 modes, automatic and the manual modes. The automatic mode performs an AI-powered analysis. So this feature leverages our LLM-based query routing system that dynamically determines optimal data utilization strategies based on your coordinates and descriptive inputs. So This sophisticated routing mechanism evaluates your requirements and autonomously selects appropriate analytical services while identifying the necessary input parameters for location-specific model execution. The system maintains complete transparency through dual mode operation, delivering automated results while simultaneously exposing the underlying LLM decision-making process, enabling you to refine and iterate upon initial determinations. So this is the manual mode. Second mode, for experienced users who prefer granular control, our manual mode allows you to directly interact with the features like dataset indices, inputs, outputs, and models, like this. And however, if you are new to the platform or don't have extensive technical knowledge, we strongly recommend you to starting with the automatic mode. So let me perform a live demonstration here. In this tab, I'll use our annotations tools to select a location and pose this question. So let me write, I want to build a system here. What happens when an earthquake occurs in this place? And can you find similar places? So this is my query, and I will choose a target country, target region. Let me choose Turkey. This is the country where I'm from. So I will choose a region of interest. I can select the polygon, I can select the circle, and I can select the box. So I will go with the box, and this region is okay by me. Once I select this region, I will be able to run my experiment. So when I press this button, our LLM querying mechanism works. Let me just demonstrate. Now our experiment is running. Our LLM determines that we should use the Turkey's use case data, then automatically selects aligned models and data sources. So the system feeds the model with the user's desired changes to the data, allowing us to see results from similar locations with comparable ground conditions and different feature levels. So this is the interface where we can observe the results. The similar places correspond to the region of interest that we chose for our experiment. And once we run the experiment, we get comprehensive results for places where we have data in our data cube. So here you can see different locations where users can explore various outcomes with their desired change in the area of interest. So at the bottom of the results, you can see the match services like this. So what are they? This is our innovative matchmaking tool. So let me explain what makes this so powerful. The matchmaking tool serves as an intelligent bridge between users and European Earth observation products and service providers available and EOMO, Earth observation mode. It's designed to connect you with relevant EO-based solutions that align with your specific developments and ideas and needs. So let me further explain how it works. You can see the results here. So it's actually a four-stage process. So the stage one is intelligent keyword exploration. When you enter your development idea and complete the form fields, our advanced natural language processing system using Llama plus LangChain analyzes your input to extract relevant keywords and themes that reflect your true intent. The next stage is database matching. The system compares your extracted keywords with our structured database of European EO products and service providers from EOMOL to find potential matches. And the third stage is our scoring algorithm. Using cosine similarity and Elasticsearch, we measure how closely each EO service matches your needs, scoring each identified service based on the relevance. And the last stage is the optimal recommendations. So finally, we present only the top 2 highest scoring service providers directly on your screen, ensuring you get the most relevant recommendations without information overload. So this AI-powered system facilitates user data matching, enables collaborative features by connecting users with similar interests, and incorporates feedback integration for continuous improvement. So let me show you one. As it opens in the background, I will move to the Use Cases tab. Finally, let's explore our Use Cases tab, where you can discover detailed information about our various applications, their descriptions, and use topic filtering to find exactly what you're looking for. So let me demonstrate. If you seek to find topics by earthquake, you can just click and activate filters. If you can click again, it will deactivate. So yeah, this section helps you to understand the full scope of what's possible with UDENE platform and provides inspiration for your own projects. And you can see our matchmaking tools results. It directly navigates you to the website. So as conclusion, to sum up, we've explored the complete UDENE Exploration Tool workflow. It can be comprised as easy registration and secure access, comprehensive datasets from both in situ and satellite sources, powerful automatic and manual experiment modes, AI-powered analysis with transparent decision-making, intelligent matchmaking with European EO service providers, rich use case examples for inspiration for custom projects. And the UDENE platform represents the future of Earth observation and data analysis, combining the cutting-edge AI with comprehensive data sources to support informed decision-making for urban development and environmental research. So I would be happy to answer any of your questions about the UDENE Exploration Tool or demonstrate any specific features in more detail.
So this is all for our demo.
Thank you so much for the very nice videos. We will quickly move to the introduction of the Serbia and Tunisia use cases. So I ask Nicola and Mohamed in this order to take over for the presentation.
Okay, thank
Yep.
you very much. You hear
Please.
me, I guess? Yes.
Yes.
So also let me know if you see my slides.
Yes, we see it.
Okay, thank you. So my name is Nikola Brenovic. I'm a senior researcher at the Bioscience Institute. We are a research and development institute which is building IT solutions and innovations in agriculture, biosystems, but more and more we are moving towards sustainability, either in urban or rural development. And in particular, I will be introducing today Novi Sad use case. Novi Sad is the town in northern Serbia, and currently we have two major traffic infrastructure changes being built or planned. And what we wanted to see with this use case is how much those traffic changes, infrastructure changes, will actually affect the air pollution in our city. So the first change is building a southern bypass that should divert the heavy traffic around city of Novi Sad, and the southern bypass includes two new bridges. While the second, which is still planned, change is actually turning a heavy street with heavy traffic into a pedestrian zone in order to preserve the historical core of our town. And to implement these use cases, we combined various heterogeneous data sets about traffic or traffic infrastructure, meters, pollutants, emissions, both coming from in-situ data and the satellites, and also some microcensus data which we had available for our town. And what's important to mention, we utilized traffic potential data coming from Professor Marina Carevic-Tomic from the Faculty of Technical Sciences in Novi Sad. And basically what we wanted to see is how much we can use this data instead of metered traffic data, because there's two different ways of how obtain with these two data sets. We used two approaches, one microscopic based on regression models and microscopic based on agent-based models. So for the first one, we evaluated, tested different settings, different configurations of various Bayes models, linear regression models, polynomial regression models, decision tree, and random forests, with the last actually coming to be the best in order scores. So at the end, this random forest regressor turned out to be the most useful and the most precise model. We also applied sensitivity analysis both globally and locally in order to determine the minimum set of data which are actually required for these models to be run, so that we are able to estimate air pollution. On the microscopic scale, we actually turned to agent-based modeling, which is very good because we present each particular participant of Novi Sad transportation system with a single software agent. We can mimic the behavior of each inhabitant, basically each participant in the traffic. On the other hand, these models are very challenging because of the usual lack of data what we have in the city. So we need a lot of data about how the people are acting. And we had some microcensus data, but that was below 5% of the inhabitants, so very, very few. And for this reason, we developed state-of-the-art algorithms for the generation of both households and population. Basically, we synthesize the data which we need to run the agent-based models. And the next step is actually to mimic and to synthesize the activities of those agents. So basically, when they are getting up, when they are leaving to work or to school, what they're doing on their way back, which travel mode they're using, and so forth. So for these two things, new and quite sophisticated algorithms had to be developed, and at the end we are able to basically simulate how the people in Novi Sad are actually using the transportation system now at this state, or when we imply different infrastructural changes, so those new bridges or the or turning a street into the pedestrian zone, and from there to estimate on a very granular way to estimate the air pollution. So thank you for your attention. I invite you to listen to the full presentation of our use case. I think it's available on our channel here, on our channel social networks, and also send us any questions if you have. Thanks.
Thank you. We can move now with Mohamed. Now you are connected.
Yes, please. Could you see my screen or not yet?
Yes, yes.
Okay.
Perfect.
Is it full screen now?
Yes, now it's full screen.
Perfect. Hello, everyone. I'm Mohamed Rashhi. I'm a remote sensing scientist and project manager at the Tunisian Space Association. Now I will present the Tunisia use case. It's about the effect of the linked park system on heat load. So this presentation is divided into 5 sections: the use case introduction, the study area, the input predictors and outcome variables, methodology and results. The Tunisia use case, as mentioned, is about to study the effect of the linked park system on the heat load. So this is the core development idea, and it revolves the creation and enhancement of a linked park system to mitigate the urban heat island. So the urban heat island is the difference of temperature between rural area and urban area, and it's usually the rural area is lower temperature comparing to cities, and it involves the strategic design and expansion of green spaces, parks, and urban forests. The study area is located in Greater Tunis. It's in the northern of the Tunisia country, and it includes 4 regions: Tunis, Ariana, Manouba, and Benarous. So the study area is covered about 256,000 hectares with about 2.6 million inhabitants. And the area is characterized by high urbanizations with dense residential, commercial, industrial, and institutional areas. As well, it's characterized by different land cover land uses, such as the wetlands, urban green spaces, lakes, built-up area, and airport. And for this use case, our temporal scope is seasonal change in 2023. So our concept is we have input predictors and processed. This inputs are processed with models, prediction models, to get the outcome variables. So our input predictors are sourced mainly for spectral indices from Digital Earth Africa DataCube, for urban green spaces by Google Earth from Google Earth Engine, global human settlement layer from Copernicus, land cover by European Space Agency, and local climate zone by WeAdapt. Here's some sample input predictors that you will find in UDENE DataCube. As you can see, seasonal change of the land surface temperature, local climate zone, and as well urban green spaces. So regarding the prediction model, we tested different model with the highest accuracy is the random forest regressor to predict the surface urban heat island, and we used the formula to calculate the surface urban heat island as the difference between the land surface temperature of every pixel in urban area minus the land surface temperature of the dense forest. As a result, we generated the surface urban heat island real maps and the surface urban heat island simulation under different scenario. So in the left side, you can see the surface urban heat island real maps for the 4 seasons. And in the right side, the same urban heat island, but with different scenario. Here we increased the urban green spaces. So we supposed the implementation of new parks, and you can see that the temperature in the city, so the urban heat island, is decreasing. Yeah, and thank you for your attention. If you had any
Thank you,
question.
Mohamed.
No, thanks.
So to stay in the time, I remind to the public that the questions should be sent to the Q&A tools, which is nearby the chat. So we have an order later for reply. Thank you. And I think we can move directly on the focus presentation of today, that is the Istanbul's use case. So I invite Professor Lenk for the introduction.
Thank you, Daniel.
Yes, we can hear
Good
you.
afternoon, everybody. Let me to share my screen. Is that okay?
Yes, it is.
So, I am Onur Lenk, and on behalf of my colleagues working together at NIC System, would like to greet you all from Istanbul. And we would like to present our presentation given in the slides shown here under the following topics within about 25 minutes or so. NIC System operates in the field of remote sensing since 1969, and she is expanding her product portfolio with value-added services along with her international partners. In our Horizon Europe project, UDENE, we accomplished two major tasks. First one is the design and development of UDENE Data Cube, and the second one is the implementation of Türkiye's use case, which is the focus of this webinar. The implementation of Türkiye's use case is an ambitious and mostly public concern topic on earthquake preparedness in the context of the high-rise urbanization in the area that we live here in Turkey. UDENE Geospatial Data Cube, by definition, as you're all aware, a data cube is a multidimensional array or structure used to represent and analyze data in multiple dimensions. It is actually a data management system for spatiotemporal, that is the time and space dimension data from space sources of different ranges, and both satellite-based and terrestrial-based sources such as satellite imagery and local sensors. And the most characteristic feature of the data cube that we have developed in the UDENE project is its structure, which is developed within the scope of this project and plays critical role by providing analysis-ready data for natural experiments to be implemented by exploration tool that the OSBE has declared just 5 minutes ago through the three use cases, Tunisian and biosense use cases, as well as our use cases in the area. So we store analysis-ready data for all the tools in our project. This is the architecture and the system flow of the data cube. In the data cube system, data flow starts with the processing both vector and raster data. In the right-hand side, you see you're utilizing the UDENE Data Cube tools that we have also developed in this project. The converted data is transferred to the UDENE Data Cube in accordance with the database which is being stored in PostgreSQL, and with employing the data from in situ data from municipalities, regional data from cloud, and also linking the data from other Earth data cubes. Now, this is the general infrastructure, and we also have direct access to the UDENE Cube is provided UDENE Data Cube services here. These services have two main components. One of them is the web front-end application, and in the front-end application allows users to create data and visualize the analysis results. And the other API that we have provided in Data Cube services is the backend application, which hosts the backend services and acts as a bridge between the client side and the data service. The Data Cube engine is directly related with the three different use cases developed in the UDENE project. Two of them that you have listened, but with from my colleagues, and the other is the last one is just I am talking about this now. These scenarios represent the novel analysis algorithms developed by all our international partners. Each scenario performs its own custom analysis with the data it retrieves from the data cube. In the left-hand side, you see two main applications of the system that work at a high level are the exponential tool and the matchmaking tool. These are also mentioned with my colleague Ozbey 5 minutes ago. Both tools meet their data needs through UDENE data cube that you have seen its structure now in the slide. Now, let's quickly watch the video recording that demonstrates certain functions of the UDENE data cube now. Let me 2 degrees. First one is the adding the VMS services. Decrease the volume from the catalog data and the in the UDENE data cube services. And also you see all the map layers here, and you just play around the transparency of those VMS data, and also you can add some more data from Copernicus land monitoring services. For example, now we are just adding another VMS data onto map OR data cube. Again, you can shift around or play around the transparency level of each spectral bands that has been provided and already stored in our data cube. Yeah. And data cube querying is having some similar tools that we have experienced by Exploration Tool. By drawing an interest of area in anywhere, you can select the respective datas which has already been separated in different bands and stored in data cube's original file format. Here, for example, you see Sentinel L2 bands here, and again, you can select those datas and deselect them and focusing or zoom out all the features provided by the functionalities of DataCube. Let's see some more in situ data which are critically important for the use cases. This is the Jupyter notebook of the DataCube. You see the every kind of data which have already been stored, transferred by all our use case developers. For example, you see here the raster data in .eml format, and other data sets which have been already provided by Tunisia, for example, Biosense, all provided and stored the data as a local in situ data in our data cube. And lastly, you see our Türkiye use case data, polygon data, either raster or vector data in our Jupyter notebook environment of the data cube. Of course, you are selecting those data on top of a base map, and you just visualize the maximum minimum coordinates in WGS84 SPG, as you're all aware. And you select the data or deselect the data, different spectral bands of the satellite imagery. Again, another data from Europe, biocell data, and the local institute data from Turkey's use case. Once more, you see the area coordinates, boundary level information gathered from the metadata of the local institute data stored in UDENE data cube. And as soon as you select and visualize all the data, local institute data, together with the global data, you can select those data, and as soon as you select, you just visualize them on top of our base data provided by UDENE Data Cube. So as a last step, use case vector data sample. Here we are again in the phase of the Jupyter notebook of the UDENE Data Cube. In our use case, for example, we have dumped all vector data pertaining to the building damages due to the scenario earthquake happened in the Istanbul region. And they're all geocell coordinates as well as the damage levels of each cell that we have estimated through our use case tools. And pertaining economic losses, damage informations are displayed in geocells format, as seen here in the top of the layers. You can click on the geocells, which have about 450 meters, 400 meter cells, and you see the cell numbers, XY indexes, populations, quantity of the damage levels, and economic loss that have already been computed. You can easily visualize throughout the utilities provided by UDENE Data Cube. Okay, Turkey's use case. As we all aware, the earthquake phenomena has been the focus of our use case. Our purpose is just to determine the high-rise district effect in the context of earthquake preparedness. We specifically aim to explore evidence-based land using planning by estimating the possible building damages and their respective economic loss of high-rise urbanization due to an earthquake that we are going to exert in the Marmara region, Istanbul, Marmara Sea, North Anatolian Fault Zone. These high-rise urbanization damages are so much prone to the earthquakes having a magnetic moment of 7.0 or greater in such tectonically active regions. Our approach highlights the critical transition between hazards to the risks. From hazards, this is the natural seismic energy, to the risk, which are the human and economic impact, emphasizing the role of urban planning, structural resilience, and modernized design codes in mitigating seismic consequences as well. This is our use case revolving concept from hazards to the impacted risk map, utilizing all the settlements that have been developed by humans. And our use case concept focuses high-rise urbanization that I have mentioned ago. High-rise buildings are more sensitive to ground motions, as you're all aware, with longer periods. The probability of collapse is higher for purely designed or older high-rise buildings, particularly those without modern seismic standards. Now, with the ability of our concept, we first explore the scenario-based earthquake damages in such a tectonically active area in Istanbul, using the structured local institute data, either from the data cubes, or from our data cube, and or other cubes for the urban environments, and we try to assess possible effects of high rise for earthquake resilience and sustainable land use urbanization. Now, we would like to show you our use case area of interest, which is the sub-district area in Kadıköy, Fikirtepe area, which is very populated with high rise within the very short widths of the streets and modeled in the area. This is the Kadıköy Yeni Fikirtepe area. It is in the scope of urban transportation since 2005. Approximately 15 old buildings are targeted transformed. In the context of the new project implementation, height is set to 80 meters. This is almost 25 or 27 floors, as you see here in the video. And we are all having 20-meter wide main street. And also we are having some 12 to 15 ranges of street widths in the area. Turkey's use case implementation areas are mapped here in this slide in the hazard map prepared by Minor Research Institute of Turkey, MTA. In the first area that we have spoken is the Istanbul area, in the greater area Istanbul, and both in the sub-district of the Fikirtepe, Kadıköy area. In the second and the third areas that we have performed our competitions is Izmir area, and the last one is the third location is the validation area. In validation area, our model outputs have been validated with the governmental reports for the earthquakes happened in 2023 Kahramanmaraş, Pazarcık, and Elbistan earthquakes. So we have just validation sense in the third area, implementation area, but these rest of the two areas are not scoped in this presentation. The use case implementation scheme comprises four main steps actually. The first one is the implementation of scenario-based earthquake, having a magnitude moment of 7.4. And the second phase, we perform ground motion estimations. Here we produce building damages and their respective economic losses. And immediately in the second step, we propose recommendations for the competitions that we have performed in the second step above. And in the last step, similar analyses are performed and they are displayed for the earthquake-prone other locations in Europe, just similar to that of Istanbul, facing major earthquakes in the future. Our use case implementation methodology depicts here in this figure. We have actually three assessment phases. In the first hazard assessment module, we again compute the ground motion intensity estimation, starting with a deterministic earthquake, scenario earthquake. And we here produce shape maps. Also, these shape maps are the PGA, PGV, and spectral acceleration maps, together with the intensity maps, are utilized in the building damage assessments, as well as in the quantification of the economic loss, either direct or indirect. In the last urban development assessment phase, we implement spatial statistics and drive some policy outcomes in our use case implementation. In this slide, you see our main inputs variables and the output variables. In the left-hand side, the input variables, but our primary variable is the introduction of the earthquake magnitude, together with the geographic coordinates of the epicenter and the depth of the focus. By starting this, we input some data, either in default vector data or the raster data. Vector data, for example, coming from the fault line data, either global data centers or from the data center of MTA, Mineral Research Institute of Turkey. And also we input the shear wave velocity. This is the V30 data sourced by the United States Geological Science Maps. And lastly, the most important data is the building data inventory. It has been also sourced by so many local institute municipalities, for example, satellite imaginary data, all compiled the building data inventory. The building database obtained from Corinne Land Cover population database in 2000 It is provided in about 150 arc seconds for 27 European countries, which the coordinate data were available, and all the distributions have been arranged for the buildings. Each building class has been defined specific taxonomy. In the output variables, we estimated the intensity maps, estimated building damages, and corresponding economic losses. These are in this slide, you see some other data sources other than the data sources that I have mentioned previously. You can see the similar inputs, similar assessment tools, similar outputs. For example, for your seismicity of your geography, you can just look for those URL sites, for example, Global Seismic Hazard Map, GM risk tools and data. And for the ground site condition of the place where you live, this is very important, site corrections point of view. You can just search for the Eurocode 8 from this URL address. And also you can just explore EU soil database from this URL. And lastly, the structural conditions of the building that you are living in your area as open call users, you can just go to the Eurocode 8 seismic design regulation in this URL address. And also you can check for Turkish earthquake code TSE 2018 from this URL. Dear participants, the critical data in our use case is the building inventory data. Population, arranging the building inventory is much of concern, and it's a burden of our work in the implementation of our use case. This data, building data, is in the vector form from respective regions, was obtained from OpenStreet Maps building data. And the data has been checked and organized utilizing the high resolution maps ranging from 15 to 50 centimeters in World View 3 satellite imagery. And then we just explore, delve into our use case area and combine them with the images and taking into the account of the sessions, of the missing sessions, we just make some rearrangements. The polygons are created and the vector dataset was completed as to be inputted for the building damage estimations. Those estimations are carried out in geocoded cells shown in the left bottom center, having a range of 150 arc-second grids in Greater Istanbul area and the 19.6 arc grids in the sub-district area of Fikirtepe. In our estimations, first we compute ground motion parameters like PGA, this is the peak ground acceleration, and peak ground velocity, and spectral acceleration. These are the parameters of the ground motion, actually. And by giving an epicenter coordinates, magnitude, and depth, using the ground motion prediction equations, GPM, specifically chosen for the area. This GPM equations, GMPE equations, excuse me, are chosen specifically for the area of Istanbul. The intensity-based empirical vulnerability relations are developed by research community, by Lagomars in a Giovanni study 2006, and we are just used in our building damage assessments. Now let's watch how we estimate them through the utility that we are employed in our use case. Let me decrease the volume a little bit more. We used LR software developed by GRC3FPE FramePeg program of 6 in the collaboration of Boğaziçi University Earthquake Research Institute Kandilli, and together with the various partners of European countries, or so many European countries. We first input our manual data in the this level of competitions. This is the MATLAB environment. It is running in desktop. just we have recorded. Now, according to the inputs that we have entered, we computed the intensity distribution maps, as well as the PGA, peak ground acceleration, and peak ground velocities. And also, with the intensity grids that we have entered, it is possible to compute the total causalities, but which is beyond our scope. And later in this utility, we compute the building damages utilizing the ground motion estimate parameters that we have computed in the first step. These damages are being displayed for different level of damages, D1, D2, D3, D4, D5. For example, you see the D5 heavy damage this in the Istanbul area, utilizing the scenario-based earthquake of magnitude 7.4. And you see the distribution damaged buildings, and consequently, we compute the economic loss pertaining to this D4 building damages that we have computed in this algorithm. Sooner also, we compute the more intense, utilizing the more intense building data. We compute the spectral accelerations and drive their graphics at 1 second or 10 seconds more. And this time we have 3 different damage levels for the Fikirtepe area, which we focus intensively. And in the slide, you see the economic loss as well as the distribution damages within the 12 geocells that we have divided in our Fikirtepe area of interest. Okay, these are the, if we look a little bit look closer to the outputs that we have computed in this slide, distribution of damaged buildings in D4 level, which is a very high damage buildings, reinforced concrete one in the left top side, and the right hand side. In order to compare the high rise, we have already computed the low rise reinforced concrete very heavy damages. And at the bottom, you see the D5, which is the destruction level of damages and this of distributed buildings. In the left-hand side, you see high rise, and the right-hand side, you see the low rise graphics that we have produced. And also here in this slide, you observe the economic losses pertaining to the all damage levels of building and losses in the area of interest. Dear participants, economic loss is essentially the translation of the physical damages that we have produced into the total monetary loss using local estimates of repair and reconstruction cost available in our database of the utility that we have computed. Here in this left-hand side slide, you see the distribution damaged D3, D4, D5. D3 is the heavy damage to strong damage. D4 is the heavy damage, and the D5 is the collapsed level of state damages. Let us to concentrate the high rises, having our stories 9 to 20 stories or more. Here we see about 13,000 over non-damaged 44,000 reinforced concrete high-rise buildings in Istanbul area, Greater Istanbul area. In the right side pasta diagram, you see the comparison of high categories in RC reinforced concrete. Low, medium rises amounts to about 900,000, and high rises amount 44,000, and all rises for all building types, including reinforced concrete frame, masonry, or other types of building constructions, that they amount about 1.2 million for the sake of comparison, you can observe this slide. And of course, utilizing this LR software, you have choices, other choices to compute the intensity damage estimations. You can explore more by just getting through those URL addresses to compute the similar parameters like PGA, ground shaking intensity, or the PGV in our use case. So in your use case, in your area of interest, you can try and explore those URL sites other than the software that you can also compute those quantities either by downloading the LR software or the other softwares that has been already shown at the bottom of the slide, like Selena software, Q-Alarm software, and SEDIM software that's been already their URL addresses have been given. So let's look a little bit more closer to the damages that we have obtained from Fikirtepe, Kadıköy area. As you see from the video, it's very highly populated.
Not to be rude, we are a bit running out of time, so we can ask if we can shorten a bit the description.
Okay.
So
next
thank
two,
you
three
so much.
slides. Thank you, Daniel. Our area of interest is about 3 kilometers square, and we also computed the building damages and the respective economic losses for 12 geocells. And here you see the 12 geocells, and also you can visualize the 3D visualization damage levels in reconstruct buildings in this graphic. And the most important feature that we have obtained last 2 or 3 slides that we got from the building damages is the importance of the partial or total failure of individual towers, high rises. At 8-meter width streets, roads, there is a very high risk of blockage with D1 and D3. Together with the D5, it's also a debris shedding all the streets. And at 18 meters, the blockage risk of the debris of the building damages reduced, but still notable due to the large number of slightly or moderately damaged buildings. And you can also see our implementation areas, similar areas throughout Europe, since we are all living in the same tectonically active orogenic belt, extending from the Himalayan in Asia to the Alpine region in Europe. We estimated all the Athens, for example, damages, and the Rome damages, for the city of Rome in Italy, all the damages pertaining to the earthquake vulnerabilities. And here you see our UDENE Data Exploration Tool giving some similar information that the OSBE has occurred at the beginning of our presentation.
Okay, thank you. Thank you so much to be.
Okay. I would like to skip this since similar information are given in this video. Skip to our results. Our results are the high-rise zone of Fikirtepe with narrow streets ranging from 8 to 12 meters, having 7 meters tall. Under the following damage estimations, collapse scenarios, debris blockage risk, economic losses have been obtained. And the last slide is our derivation of policy implications for urban development perspective under 5 important headings. The most important one, high-rise construction in narrow street environments must be critically reassessed. Future planning should adopt minimum width to height ratios for streets to prevent complete blockage during collapses. And lastly, we need to land use and redevelopment policies which must integrate seismic risk layers, ensuring that the densification through vertical growth is aligned with the lifeline's resilience. Thank you very much for your patience.
Thank you so much, Professor. I know we have the demo also now with SEDA, or we have everything.
No, That's all the
okay.
That
so
is all the Turkey's.
Thank you.
Seda has given already a short presentation 1 week ago. This is the all complete demonstration of UDENE Türkiye use case implementation.
Thank you so much, Professor. So I see that we can just pass briefly on question and answer session, just 5 minutes. I see there were some questions that were unanswered on the question and answer tool. Here we have a question, I guess, for a top university that I don't know if you can read directly, but they are asking if they understand correctly, the experiment selection allows users to access relevant dataset platform or related to their prompts. Is that correct? Or it does also have the capability to make spatial analysis experiments itself? I don't know if we can catch up online with that, or we can move it to the collection of frequently answered question. I ask Maya, that is.
Yeah. We had a little bit of a technical issue with the Q&A. Some of our partners couldn't access them, so we caught up with the question a little bit late, and a colleague is preparing it, and Fanny will, I think, give an answer in a second. So we can, if you have any more questions, please ask them now. If not, then there it is. The question is answered, so you can see it. Fanny, thank you. And if you have more questions, do not have questions now, but you get questions later, please use the links we provided, or the email for the questions, info@udene.eu, as we shared. And the first question, I can read it out, Daniela, that can help you out here, is do you have any school presentation winners so we can see if we can participate as well? So thank you for the question, and we answered. You can please go see the first Annex 1, called Fichet, where you can see your eligibility, where we stated the eligible eligibility requirements, and you can see them, and then you can see if you are eligible for it. But regarding the presentation that you can kind of overview, the open call is ongoing. We do not have winners yet. It's going to be afterwards, but we cannot share other presentations and ideas with the participants inside the open call. So when the winners are presented, you can see them, but as long as the open call is running, we cannot share the information regarding that. But the eligibility requirements are in the Annex 1, as I already said. But if you have any more questions after you see them, you can also write to us and we will respond quickly. Thank you.
So we do have other questions from the public. I don't think so. I think there is a question for Professor Lenk here in the tool. So building in Fikli Pet, sorry, I cannot read exactly the Turkish, are over 20 stories, but the high classification is limited to 20. Are you using specific fragility vulnerability curves for Fikli Tip region?
Okay. Thank you for the question, Emin Bey. Yes, the buildings in Fikirtepe are over 20 stories. We have a range of building rises. Our field of area, interest area, is composing some more, a little bit more old area buildings ranging from 9 to 29 plus are categorized as high rise in our implementation. Yes, you are right. There are some 27 stories as well. Thus fitting to the 8 meters or so according to the urban renewal program. Are we using specific fragility vulnerability curves for the Fikirtepe region? No. We are just employ the Lagorzem and Giornaviziri 2009 research letter, research study. Just we are using the fragility vulnerability curves for the area, which is already using in the LR software. Similar fragility curves are employed in the programs that I have showed you. You can either choose LR or the other programs and utilizing those fragility vulnerability curves. We don't use any specific one other than the embedded one that we've already. But the building data inventory, of course, as I have mentioned, is a little bit more detailed since the urban high-rise urbanization is on agenda in Fikirtepe area.
Thank you so much for the precise replies. If we don't have any further questions, we remind that all the project partners will be available through the UDENE channel for eventual questions. I think we can close here the session. I don't know, Maya, if you agree.
Yeah, Ali. I think thank you everyone also for participating. Thank you to our presenters for all the information that you shared. And as I already said, if you have any questions, please let us know and we will provide answers for you to the best of our abilities. And enjoy your week.
Thank you, everyone.
Thank you so
Thank you,
much.
Onur Bey.
Thank you.
Thank you.
Thank you. Bye-bye.
Bye-bye.